All right, let's get to the free response and actually jump in on this. So let's go ahead. We'll get part A done. So we want to know the speed right before it hits the ground. So we start with the speed of 0, and we hit with a final speed that's unknown. So we can actually use v squared equals v naught squared plus 2 times g times the height it falls through. And since we start with the speed of 0, the speed when it hits the ground is actually 2gh. And so when we plug in our numbers, it's going to be 2 times 10 times 5. And it looks like our speed ends up being 10 meters per second. Awesome. Now, it seems to rebound with the same speed that it hit with. So that speed going upwards is going to be 10 meters per second. And the other one's dropped. So let's actually go ahead and set up equations for both of these. So what we'll say is this. We'll say x for the dropped one is, and we'll say this, we'll say y for the dropped piece of clay is going to be, and I'm going to be really careful here, we're going to say that we're going to call downwards the positive direction. So we're going to have 1/2 times gt squared plus 0 times t, and we're starting at a height of 0. This is the one that's being dropped. Now, for the one that bounces off the ground, okay, again, it's 1/2 gt squared plus, since we're calling downwards negative, be really careful. We're going to say that here our speed is -10 because upwards is the negative direction. And the position that it's at is it's actually at that height that it's on the ground at, which is 5 meters. We got to be super careful with this kind of stuff. Okay. Now we want to know when they hit each other, so we can actually go ahead and set that up now. And what we know is that they meet in the same place. So yd dropped equals y bounced. They actually have to meet in the same place. So we can set those two equations equal. When we do that, we're actually going to get -10t plus 5 equals 0 when we simplify, because this stuff's going to cancel. And so we're actually going to, they meet at about 1/2 second. And the height at which this happens, well, we can just plug in y dropped is 1/2 g times 1/2 squared, so that's going to be actually 1/8 times 10. And let's actually go ahead and solve that. So 10 divided by 8 ends up being about 1.25 meters high. And in part D, we'll actually do all of this in terms of letters.